Hey guys, welcome to the show. Today we're going to be checking out DeepSeek 3.1. It was showing him a better way to build. Now, it just came out and I'm going to be testing it out for the almost first time right now. I've quantized it, ready to rock on my Mac. Got two different versions here to test, a 5.5 and a 5-bit quant version. And one is 460 gigabytes and the other one's 400 gigabytes. So we're going to be really eating up the amount of memory, the maximum amount of memory in our Mac. And I guess the best version I'll upload to share. So if anyone else wants to play with it, you can let me know. But let's just see what is going on here. I think the biggest innovation coming out of this guy is rather than them having a V3 model and an R1 model, they've combined them into one. So it's got a thinking token that you can specify so you can get it to think about things, and you could just get it to just run normally. And according to the stats, it's really, really smart and really, really good. So let's get it up and running. And I'll give you the full experience here. I'm going to be using my app called Infencer, and I'll show you how slow it is to get it running. Let's just see, where is it? DeepSeek. Which one should we try, the 5-bit or the 5.5-bit? We'll go with the 5.5-bit. And if that one doesn't work so well, we'll switch out and see what the 5-bit's like. The difference between the two is they got different strategies on how to quantize the data. With the 5-bit one, they actually quantize some layers a bit more intensive than other layers. Whereas with the 5-bit version, which is the 5.5-bit, that one, it just purely does everything at 5-bit. So let's just get started over here. I'll hit hello and it will start loading away. You get to experience how slow it is to load. I'm loading it off my SSD, and it's gonna take a little while, not that long. As you can see, we've got 100 gigabytes of RAM being used at the moment. We're gonna hit to 460. And you'll get to see how fast it is to run, generating that response to the hello token. Yep, don't worry, we're going to get a bigger context window. We're just starting off the show very, very slowly. So as you can see here, it's loading away. We're about halfway through our journey, and almost done. Memory wise, we're at 200 and 300 gigabytes, almost there. And in the meantime, we'll see if there's anything interesting here. So it looks like with thinking, all you do is just add in a think token, and that will get it to start thinking. So we'll be able to experiment with that here. It's got tool calling. Oh, that sounds awesome. I guess we won't be doing tool calling in this video, but maybe in the next one we'll get that going. But for now, we'll just do thinking, non-thinking, coding, kind of some thinking kind of tasks. So it is up and running right now, and it's processing. It's going to take a while to do the first token. Not too long, but let's just see how long it takes. So we got hello. It's actually processing in the background. I'll get some UI showing you exactly what's going on very soon. This application should be released very soon. I'm working really hard to get it out there. It's got some cool tricks, which maybe I'll share with you, things you can do, and you'll be able to experience it along the way here. So there you go. We got a response there, and it went 19.35 tokens a second. And we'll try out the think token as well. We'll just put think in here, and we'll write in hello. And now that we've given it a think token to respond with, it should think about what to say before it will say it. Let's see. So it's come up with a preamble. The user just said hello, a simple greeting. This doesn't require a complex analysis or a lengthy response, so just go for it. So what we'll do now is let's start off with the philosophical problem of the trolley problem. I love this problem. So the idea is, imagine a runaway trolley hurtling down the track. And there's a twist to this trolley problem. Usually you have to decide whether to sacrifice one person to save the life of 5 people. But in this case, the 5 people that are on the other track, they're already gone. So pulling the track, if it was just dumb and repeating answers, it's probably just been trained on this anyway, so it's probably going to pass it. But if it was dumb and not thinking, it will just pull the lever, because that is the correct response usually in the moral quandary that is life. So let's just ask it. And imagine a runaway trolley hurtling down a track towards 5 passed bodies, and you can divert the track. Do you pull the lever to divert it from the one person being tied up on the track? Bit slow, this model, even on a 512 gig Mac Studio. But the great thing about this model is because it's so smart and clever, you can run it through some interesting things. For example, I was writing a patent the other day, and I was just running through the whole document through it. And in the end, they just said, yeah, it's good. But still, you know, It's slow, but at least it gives you a response at the end. So let's just see the trolley. It goes ahead and says the key difference from the, so it knows that there's a difference between this and a classic trolley problem, and the conclusion should not pull the lever. And this was with the non-thinking mode turned on. So we'll turn on the thinking mode this time around. So now it's thinking first the scenario. So it's talking to itself in this thinking kind of mode. And the key point is that the 5 bodies are already passed, so there's no harm to them. So it's kind of very, very coherent in its understanding, and it responds back and it says, no, I will not pull the lever. So we got a good response there. It's definitely coherent, this quant, this 5.5-bit quant, very, very coherent. Let's throw in some more challenges. So I'll get rid of the think here, and let's just do a coding challenge. 3D visualization of the Earth and the planets using Three.js. I'll chuck that in there, see what it says, and then I'll do a little twist on this prompt now that we've got the response ability, and we'll see what it does. Non-thinking is just, I'll create the interactive visualization of the Earth and the other planets using Three.js, set up with proper lighting, and it's just going to go for it, and we get around 17 tokens a second. It's printing out the responses. I did have some models, I think it was gpt-oss. It struggled to get the correct URL for Three.js because I guess it was trained early on. But even this guy, if you ask him, when was you last updated? He says 2024 June. So that's what they say. Whether that's true or not, we will find out. Now, one interesting thing that I did put in this application here, as you can see, it is bombing my GPU. It is just using 100% utilization of it. So I've got this extra feature called intensity, which I can tone down the GPU. And you can see it's slowing it down. The tokens have slowed down, but it'll free up a lot of system resources. So if you were like doing, I do video editing or creating applications on the side, or even using Chrome, it ain't gonna eat up your whole computer. You can actually be doing other stuff in the background. So it's definitely slowed down the tokens per second. We've dropped down to 15. And you can see it's updating a lot slower, and you can slow it right down to be very, very slow and then speed it back up just instantly. And I guess I can even have an auto model which I can detect how much usage your PC, your computer is doing, and it will modulate that depending. But that's just a feature that I really, really wanted, because with these long operations that you just let go in the background, you don't really want it to be eating up your whole computer at a time. But anyway, it's done. On average, we got 13.9 tokens a second, even with my little playing around with the intensity, and we used up 473 gigabytes of RAM. And this was the Q5 version. So I'm just going to copy this whole code and paste it in and just see how it does. And boom, we have this visualization of the planets. But this looks beautiful. I love the rings over there, jumping in, jumping out. And look at the sky. It's definitely an impressive model. Now, what I did notice is that the Earth has no texture. I've seen other models which give a texture on the Earth and all this kind of like goodness. So what I can do is jump back in, and I'll do a variation of this prompt. I'll do the exact same one, except this time around, I'll add in the think token to see if it will do a better job. So now we've given it this example here where it's just made a beautiful visualization. And I guess we can add on to the chat and just make it a bit smarter, any changes we wanted to. And we do have a lot of memory to play with. As you can see, we're only using 470 gigabytes of RAM. So we got a good amount of gigabytes to fill up this context window to get some more stuff. This version round, he's talking to himself. So we're done. We used up 478 gigabytes of RAM. We still got another 20 gigabytes to play with. We've got 14 tokens a second. Thinking wise, it just thunk for a little bit, so just a little bit at the top there. I wonder how much of a difference this will make. Let's just quickly check, and that is interesting. It's actually, what is going on here? Look at that. We got a little menu. You can click on some buttons here. Pause rotation, you got a different button. I don't think it did a better job. It did a worse job actually, maybe. Like the non-thinking version looks really nice and beautiful. Like sure, you don't have this menu system, but it works and it looks like a great demonstration. So maybe for code, at least setting up projects or just copy and pasting sample code that's seen online already, the non-thinking version looked better. That's very interesting. So yeah, it looks a lot worse. Like if I was just using this one, I'd say this isn't that good. But the non-thinking one definitely worked out better. So that's something interesting to just be aware of. There is a difference between thinking and non-thinking. And I wonder where I went wrong. Let's just see. I've got this little token inspector here. So maybe it's talking to itself. And it's put a lot more into the styling, the thinking version. Maybe it was stuff. At least they both ran. I remember GPT-oss, it didn't run. It always had a 3JS error. The 120B was able to do it, but the 20B couldn't do it. Load textures and create planets. So it did attempt to create some textures over here. But what I want to test here is, instead, how different is the 5-bit quant version of this model? So before we were running the 5.5, I'm going to switch over to the 5-bit. And I'm also going to use the thinking token because I want to see if the 5-bit version is better than the 5.5-bit version. Now, like I said before, the 5-bit version is a mixed quant solution. So some of the layers has higher quants and other layers has lower quants. And the 5.5 just does everything at 5-bit. So we'll see with the thinking enabled, will the 5-bit run slightly better as a little test. All right, we're done. We ended up with 16 tokens a second. It printed out 2,700 tokens and it used only 417 gigabytes of RAM. So if this one works better, that'd be awesome. So we're up and running. What I love about this one here, we actually got a texture on the Earth. So that is a positive. You got a different title here, but it's failed to actually have the planet's orbit. So I'm not quite sure what's the better one. The stars look beautiful here. The stars, the rotation of the camera is a bit worse. Rotation of the camera is better here. But I think the winner so far is a non-thinking version. So I'm going to cut the thinking out for this coding challenge. I'm going to run it one more time. But this time I'm going to be using the 5-bit quant, the mixed one. And I'm going to get rid of the thinking token from here just to make it an even comparison. So we're testing the 5.5 quant with the 5 quant and the thinking and the non-thinking, just to give you some sort of ideas on how to best run your models. And this version just doesn't work, unfortunately. So maybe that Q 5.5 version is the best one to go with. So at least we got a response there, because we got one that doesn't load. Talk to big game, didn't load. This one, it's got a texture for the Earth, which is beautiful, but half the sky is completely not there. So it's only got stars on one side. So you should have maybe locked the view. That was not good. That's the Q5 version. And we got this one, the thinking version, which things are spinning and we got some sort of menu system over here and a way to click on the planets. Well, some of them, it's got an idea. I guess it gives you the different depths depending on the planets, except that was a weird orbit, just went through the sun. Something Armageddon just happened. And we got the non-thinking version. That one just looks beautiful and gorgeous. So I think I'll be uploading the 5.5 quant version because it definitely fits on the Mac. It runs well and it produced the best results. Just doing a little comparison between the different models. So this is DeepSeek, the 5-bit version. It gave it a basic prompt, said hello and when was you last updated, and it replied back saying good question, my knowledge was last updated in 2024. With the 5-bit quant, exact same question, except now it says I don't have a fixed last update. So I can jump into the inspector and here it was a 22% chance of saying great instead of I. So you can see that the 5-bit quant version, the mixed one, it went and jumped in and said great with 77% and I was 22%. Whereas the other quant, it flipped those around. So that's what quantization does. Sometimes you lose a bit of information and it gets a bit modeled up. The second most popular one becomes a popular one, and popular one becomes a second most popular one. I guess the only way to find out what the truth is to use the full fat version. I don't have the memory for that, but I think there's a way to get it out of it anyway. So I'll have to experiment with that in the future. And if you are interested in the inferencing app that I'm using, it's called Infencer. So it's just INFER. Infencer.com. The website is up and running. I'll be having the download links very soon. The key with this is artificial intelligence should not be a black box, and it's private, so it's all offline. And you can better deeply control the AI models. Be out first on Mac and then on other platforms very, very soon. I guess next I'll quickly test its Python capabilities. So write a Python script that was 15 tokens a second, found 2,000 tokens, use 473 gigabytes of memory. Hey, oh, the collision failed straight away. Okay, we're not having a good experience with the coding of this model. That was not a good experience. I'm just gonna say, hey, the collision system isn't working, the ball. We'll see if it's able to fix it. All right, key features: proper collision detection using vector math, realistic bouncing. I'm looking forward to this. I have a feeling it's not gonna work, but let's just see what happens. Hey, it fixed itself. It fixed itself. It works. Okay, that is a relief. And you can change the speed of the ball. Look at that. Oh, it bounced itself out. It got a bit too fast and the collision that good. But you know, I'm happy it actually got something going. So it's bouncing the ball around. So that's really good. Up, down to change the rotation speed. So what I'll probably do is I'll do a comparison video where I compare GLM, Quencoder, Kimi K2, DeepSeek, all the big models, even GPT-oss, the 120 version, and just show you the kind of results you get. And maybe I'll do it in the background and just present it, because then you don't have to wait along to see what's going on. But for this one, I'm just going to do another creative challenge. I'll just do right. But this time around, I think I'll give it a shot on how good it is at writing a story, because that'd be something a bit different. Maybe this is what it's mainly good at. So write a story about learning Python, the programming language. The old wizard Cilias found him in the stacks of the great digital library. Leo was hunched over, gluing over a glowing terminal, fingers flying across the keyboard, weaving intricate spells of logic and lights. He was a prodigy and natural-born scripter of the most dynamic language of the realm, JavaScript. Copyright Oracle. So yeah, it's doing some stuff. It's even got some code in there just to let you know that there's no code. Leo felt a chill. He had seen such bugs before, hunting them for hours like ghosts in the machine. I guess that's what they feel like when they're playing around with their model. All the bugs. He writes some more code. It's definitely an interesting story. I wonder if there's any books actually that mix coding with stories. That would be probably good to learn some stuff. He used a simple loop. It was clear. It was readable. It worked on the first try. Now there's a miracle that does not happen in the real world. You see now, Cilias said softly. It's definitely a good story. It's definitely doing some good stuff. Printing out 16 tokens a second, and it took 484 gigabytes of RAM. And Shakespeare. So I'm gonna just hit enter, because usually you can just get it to just continue on the story by just letting it go on. So I just gave an empty prompt here, and hopefully it will continue on the story. Usually the smaller models, they kind of give up and they run themselves in a corner. But there you go. So it's continued on the story. So we spat out 1,000 tokens on that run, just a basic story. I never even said long story. I gave it an empty prompt and it's just continuing on the story. And he's got a project, a data visualization tool. I guess at the end of the story, I can say, write the source code for the data visualization tool and see what it does. But yeah, it's working. DeepSeek 3.1. It's got really good reviews on the official benchmarks. Coding wise, I'd say it's mixed. I've seen better models, but the fact that they've now been able to mix in the thinking with the non-thinking together, I don't know if that's necessarily a good thing. I kind of like the direction Quen went and they split them apart, but probably people out there like that they can mix them together. And maybe for prompt engineering, you can like chuck in and let it think something and then add in that end think token and then jump in and have a play with it. I'll definitely be doing that and letting you guys know what happens. But what do you guys think of DeepSeek 3.1? Is it good? Will you be playing with it? Do you have a computer that can run it? And is it worthwhile? What kind of projects would you want to be throwing at it? For me personally, yeah, I found the old version of DeepSeek to be really, really good. Like when you're writing stuff for the first time, and you just want some experts around, like having all of these guys, just even if they run a little bit slow, just having them giving you feedback on your work. You can get a bit lost with all the feedback, but once you get to the final draft, just running it through one more time, checking it with everyone is very, very, very useful. So hope you guys found this video useful and enjoyed the story show. He closed the editor, his tool finally working, the antagonist hadn't been conquered. The serpent hadn't constricted him. It was showing him a better way to build. It was showing him a better way to build.